everyone, and welcome to the Aircraft Certification Channel. I'm Clarissa Fidel, and together with Rafaela Caio, we create this space to share information about aircraft development and certification. So if you are passionate about aviation like us, subscribe to our channel and hit the bell to be aware every time that we upload a new video. Today, I will be talking with Anna Sordi. Anna was here with us before, talking about fire prevention and protection. So if you didn't watch her video yet, you can do that now, clicking the link that will appear in your screen. Anna has been working with Powerplant fire protection and engineering and nacelle installation for over than 20 years. And currently, she is participating in the discussions of the fire test in the SAE A22 committee. So welcome aboard, fasten your seatbelt, and enjoy your journey. Hi, Anna, how are you?
Hi, fine, how are you? And thank you for the opportunity.
Thank you for being here with us again. So today we'll be talking about the fire protection means for the engine and APU, right?
Yes, that's correct.
Okay, so can you explain what are those fire protection means?
Yes, fire protection means are the features we have to control the fire, control and extinguish the fire after it has initiated. So the fire is already there, and what you do to contain and extinguish that. The main fire protection systems are fire detection, shutoff means, and fire extinguish. There is another common feature, that's the fire containment. But this one is not a system. It refers to have the fire zone boundaries being able to contain the fire for a while, so those other systems can be activated and actually extinguish the fire before the fire spreads to other zones. But this is a long and very complex subject, so we may leave that for another video.
Sure, I will be glad to have you here talking about that in the near future. You have mentioned in the last video that those protections depend on the type of fire. So this type of fire can influence the type of protection that will be chosen or the one that will be more effective. So what are the fire that's expected in the engine and the APU compartment?
Yeah, I brought here a figure that shows the main 5 types of fire. There are more, but those are the main 5 types. But for engine and APU, we only expect 2 types of fire. The type B, that's flammable fluid fire, and type C, that's electrical fire. This one is less likely, but needs to be considered as well.
Okay, so and beside the jet fuel that is easy to understand that is present in that zone, which other flammable fluid should be considered?
On the engine and APU, we expect the aviation fuel, as you mentioned, hydraulic fluid, and lubrication oil. So those are the 3 flammable fluids that you usually have in those compartments. On the APU, we usually don't have hydraulic fluid, but on the engines, we normally have hydraulic fluid as well.
Okay, and how the fire type can affect these protection systems?
The first step for the fire protection is to detect the fire. And the type of fire detector is dependable on the fire type. Flammable fluid fires, they have high heat coefficient. And on engine and APU, we know where are flammable fluids as well as ignition source. That's a good advantage because we know where the fire is most likely to start. So considering that, for engine and APU, the best method for fire detection is a sensor that reacts to the temperature, covering those zones, those areas where it's most likely to the fire to start. For example, an example of those areas are the combustor case region, the accessory section, the oil tank. And usually there are two types of fire detectors, the thermistor and the pneumatic. The thermistor type, it changes its resistance with the increase of the temperature. While on the pneumatic type, the pressure inside of the sensor changes or increases with the increase of the temperature, triggering a switch and providing the alarm. The main requirement for the fire detection system is 1203 for part 25 and 2440E for part 23.
Okay, so there are specific certification requirements to define the type of not the type but the behavior of the fire detector.
Yes, that's correct. Those requirements ask to have the fire detection, provide some guidance in terms of response time, location, and things like that. Yes.
Okay, and how you define? You mentioned about this, the response time and the location. So how you define how many detectors you need? That's one is enough, or you need to have several? How you define if you need to have a redundancy or not?
Yeah, of detectors depends on the area that needs to be protected and the temperature range. So usually both detectors, as can be seen on the figure, they are linear format. So you can like a wire. So you are able to cover a large area with them. But even though, because of installation issues and also the temperature range or set point temperature, usually for engines that are large compartment, use more than one. It's required more than one detector. APUs, they are smaller, so normally one detector is sufficient. So really depends on your installation and the temperature of your set points that you define how many detectors you need. Also, you can have two detectors covering exactly the same area. This is used normally to improve speciality, reliability, or minimize false alarms, depending on your logic control. This configuration is called dual loop configuration.
Okay, so then it's more for reliability and to improve the reliability of the system, but not necessarily is required by regulation.
Yes, that's correct. This dual loop configuration is not required by regulations, but can be used just to make to improve the system.
Okay. And you mentioned that the protections are detection, and then you have the subsequent actions. So after the fire is detected, what do you do to control it? What's the next steps?
Yes, as on engine APU, the most likely fire is flammable fluid fire. That's why it's important to know your type. The best means is the shutoff means. Shutoff means stop the flammable fluid source. So that's the best protection. The best way to control is if I have a fire that's from flammable fluid, I remove the flammable fluid. So I stop that. This feature this one is mandatory by certification requirements for Powerplant compartments. And the requirements for that is 251189 for part 25 and 332440E for part 23. Usually, the shutoff valve stays outside of the fire zone for fuel and hydraulic fluid. For lubrication oil, sometimes we have smaller systems that are contained within the fire zone. And on those cases, if the system is made of fireproof materials, it does not need shutoff means.
Okay, so then now we need to explain what is fireproof.
The definition of fireproof is the capacity to withstand at least as well as steel in dimensions appropriate for the purpose for which they are used. What this really means, what's the intent, is to have a material that can withstand the fire for a while, for a period, to allow for the protection to act. So on this case of shutoff means will not allow more flammable fluid to go into the zone. So we contain the flammable fluid and do not allow to increase the flammable fluid on the zone. So it can be used, as I mentioned in the beginning of the video, for contain the fire to not spread to other zones. In this case, is to contain the flammable fluid and not put more flammable fluid into a fire. So that's the intent of the fire.
Okay, I have a question about this. Is this time defined by the rule or any guidance material that define what is this time, or it depend on the type of the airplane and how you define the time that you need to guarantee that the equipment will not propagate the fire?
Yes, we have some definition on the AC. There is an AC 20-135. That's even the AC that's being discussed on the SAE committee. And it defines fire resistance as 5 minutes and fireproof as 15 minutes.
Okay. And
in case of the flammable fluid, sometimes only fire resistance is sufficient because we have 5 minutes to have the shutoff means, and then 15 minutes for fire containment. So really depends on fire resistant fireproof. On the oil system, we do need 15 minutes because we are saying that we will not have shutoff means. So we need to extend the 15 minutes. That's the time to really extinguish the fire. If we are talking just a normal flammable fluid line that will have shutoff means, fire resistance capability is enough.
Okay, well, very interesting that this difference. So that then you address that more deeply when you're talking about the fire containment, right? In another video. Okay. Okay, so then you do that. So you detect the fire and do the shutoff. You do the shutoff means, and then you may need to extinguish the fire that is there. So what are the fire extinguish system that you mentioned about?
Yes, sometimes only having the flammable fluid shutoff means we most likely extinguish the fire, but that's not all the cases. So we really do need an actual extinguish system. The extinguish system is composed by a fire extinguisher, similar to the ones we use on builds and the ones we are using, but they are smaller. And the difference that they have an outlet that can be actuated by electrical pulse. So we usually install this fire extinguisher that's also called as fire X bottle. We usually install it outside of the fire zone, and then we drive the agent from the fire extinguisher to the engine and APU compartment through pipes, and then the pilot can activate the system by the cabin.
It's not controlled automatically, right? It's the pilot that you actuated.
It's the pilot that actuates the fire extinguisher system.
So even the shutoff means, right? So when you have the fire alarm, so the pilot is not automatic, right? The pilot that you needed to do that manually, the shutoff means and the fire.
And the fire extinguisher. There is a special case for some aircraft. Only for APU on ground, the fire extinguish system is automatic, but this is really a preference of the OEM. There is no requirement for automatic extinguishing, but it's only on ground. Once we are on flight, it's really dependent on the pilot to make the shutoff means as well as the exchange. Because, for example, if the pilot's in a takeoff phase, he may choose to finish the takeoff to shut down the engine. So that's why we have those 5 minutes for the shutoff means, and also this protection. So it's really the pilot who actuates the shutoff mean. If you are on flights, the pilot that actuates the shutoff means, as well the extinguish. Also for part 25, 2 shots are required for the engine. So
okay. Which means that, so then you need to have 2 bottles?
Yes. Okay. Because each discharge must have the necessary amount of agent to extinguish the fire. So I need 2 bottles. For APU, only 1 shot is necessary for part 25, but for engine, 2 bottles are necessary. So what we do usually is that we connect those 2 bottles. So we have only 1 duct crossing the entire aircraft up to the engine compartment, just to make much easier and lighter the installation. But on this case, you need to take care, because when you need to make features, so when you discharge the second bottle, you need to make sure that the engine goes to the engine and not to the empty first bottle that is connected to. I also brought a figure with a sample of sketch of this system to show the bottle installed inside of the airplane going to the engines. Of course, this is an example. Sometimes the bottles, if we have the engine on the rear of the airplane, normally the bottles is closer to the engine and APU. So we'll varies the installation, the places where we have on the engine, but we try to put as close as we can to the engine and APU.
And you can share or not the bottles with the other remaining engines, right? Because the probability of having fire in both engines is low. That's why it's allowed. Because I'm seeing your figure that you have these 2 bottles that are shared between the 2 engines. So is that because the probability of having fire in both in the same flight is low? That's why it's possible?
Yes, that's correct. We normally need to have if it's a dual engine aircraft, you must have the probability of having fire on both engines below 10 to -9, because you need your engine. So that's why you can use both bottles just for 1 engine.
And how those bottles are sized? It depends on the agent, right? The extinguish agent that you are using, right? There's some, I know that there's a lot of discussions about this fire agent going on currently. So if you can talk a little bit about that.
Yes, that's right. The first thing is that, again, the agent you choose needs to be compatible to the type of fire you have on the zone. So for engines and APU, usually we have halon 1301. That's current the most common agent. That's an agent that's suitable or good for fire type B and C. And in order to size the system, define the adequate quantity, as we mentioned before, it will really depend on the free volume that you need to control or to extinguish, the ventilation you have on the zone, and your distribution system. And the demonstration, the certification demonstration of the adequate quantity is usually done by test. And we have an AC 20-100 that provides guidelines for this test.
Okay, and I mentioned about the discussions because we know that the halon 1301 is not really environmental friendly. And there's some work in the industry trying to replace this agent for a new one. So how it stands in this new generation of greener airplanes? So what do you think, where the industry is going on? How is the current status of this studies of halon replacement?
Yes, the halon, the problem with the halon is that it has a high ozone layer depletion rate. So in many countries, it's already that it's not allowed for everything. It only has specifically allowed uses. Aviation is one of those, but we are trying to remove it. But it's difficult because the halon 1301 has very high efficiency, so it requires low volume and low weight. That's important for aircraft. Also, it have no residue. So if you discharge the bottle, you don't need to clean the engine. You can keep flying. So those are important features that make the halon replacement difficult. But even though the authorities and the industry are really working hard in finding a new agent, as of today, we have only a few options, but those options have challenges in terms of installation and certification. So as of today, I think halon 1301 is still used, but the industry is for sure looking for that.
Okay, so you take some time still to get it to totally replace it in the future.
Yes, I believe so. ICAO already asks for new type certificates to have an alternate, but we don't have any replacement as of today.
Okay, so trying to finalize here, I know that there's also a movement in the industry itself to have a more greener airplane. So not only replacing the halon, but also replacing the fossil fuels, right? The kerosene. And so there's a lot of movement in the industry for the smaller airplane going to the more electric or total electric, so that we eliminate the fuel as a fire fire hazard. And also for the bigger airplanes going to those hybrids, that although is more greener, I think there's a higher risk or needed to have a lot of studies to reduce the risk of a fire, because the hydrogen is needed to be manipulated with a lot of care. So what would being a fire protection specialist, what would you be your considerations for those in regards of fire protection, in regards of this new greener generation aircraft?
For all electric airplane, attention shall be given to battery fire and its container qualification. Battery fires are difficult to extinguish, so the new qualification standards already consider a container, so the fire can be contained because it's difficult to extinguish. So my recommendation is for the OEMs really looking to care with those containers and apply the best knowledge on that. Regarding the hybrid, hydrogen and electrical airplanes, the attention should be given to the hydrogen fire. Hydrogen fire is also a fire that's difficult to detect and extinguish. So attention not only for how the hydrogen system works, but also attention to the fire prevention of the system shall be given on those new studies. And I think that's my recommendation.
Okay, Anna, thank you very much for being here with us. So I hope that we can do the fire containment video soon. And if you like this video, give us a thumbs up, and you can check other videos about fire hazards and fire protection in our playlist that you appear here, and other videos about fire that you have a link here, and subscribe to our channel. Thank you very much, and see you in the next video.